Hello everyone, I want to thank everyone who watched my first video. I've heard there was a bit of audio issues, so I've tried to improve the audio on this video, but I'm not certain that will work. I've also managed to work out how to give my avatar the ability to move their eyeballs, so hopefully they're a bit more engaging on today's talk. So today's talk is Cobalt and electric cars, and why mining is a necessary evil. So the inspiration for this video is this Our Changing Climate video called The Dark Cost of Electric Cars. Now I'm highlighting this video because I thought it was actually good, and despite there being thousands of the dark secrets of electric cars videos out there, this one was a good video. It just didn't really focus on electric cars all that much. And it does eventually mention the solutions, but they felt more like an afterthought on the rest of the video. So here is my contents of my talk. I'm going to talk about climate change because that's my primary concern. I'll talk about what lithium-ion batteries are, how they work, because I think some people are a bit confused about how they actually work. And then we'll talk about cobalt mining in general, before moving on to cobalt mining in the Congo specifically. And then what companies are doing for the responsible sourcing of cobalt, and can we replace cobalt entirely, as some companies are doing. Then we'll talk about mining in general and how it is unfortunately necessary, particularly when we take a look at the kind of material requirements there are for us to reach our goals on fighting climate change. How many materials are we going to need? And adding on to that is green mining in general. Can we make mining more environmentally friendly? Now, the short-term future stuff that we can do is sort of going to act as my conclusion of the video before I move on to what we can do in the medium term, which is international governance. And in the future, I'm going to have a chat about green growth versus degrowth, which I think is going to be a big concern for those left-leaning people amongst the audience. Climate change. So my last video, I went in great depth about this image, but I'm really just going to say it just means that we've got to act fast. And that basically all fossil fuel companies need to be bankrupt by 2050 or no longer be fossil fuel companies. You can see here, we need to be getting those greenhouse gas emissions very low very quickly. So I want to talk a bit about lithium-ion batteries. I find them fascinating pieces of technology. So basically they consist of three layers. We have our cathode, a polymer separator, and a copper anode. And lithium ions can flow between cathode and anode, passing through the separator through this electrolyte here. But on the anode and cathode, there is a thin layer of material. So on the copper anode, which is a bit easier to explain, we have graphite, which is a layered material that is able to conduct electricity, and the lithium can get in between the sheets of graphite, or graphene as those sheets are called, can fit in between those two layers without impeding its ability to conduct electricity. But it's the cathode that we're interested in today, because that's where the cobalt usually lies. The most common cathode is lithium, nickel, manganese, cobalt oxide. It has this kind of structure where it's sort of a layered structure between with the metals in this layer and then a lithium sort of layer in between. Because it has a similar layered structure to that of graphite, it's able to conduct electricity well, which is really important for a cathode material to be able to do, and that's why not everything works as a cathode. What is cobalt mining? Well, like most mining, there's sort of two ways you can do it. You can just dig a big hole, have an open pit mine. That's for where the ore is quite close to the surface. Or you can go deep underground. You can dig holes deep underground in a way to get ores further down. And often you can have a mix of the two of them. But that's just not enough to get the cobalt. After you have the ore, you turn it into cobalt metal. And some of these refining metallurgic methods make me, a more fine chemist, kind of laugh in absurdity or cringe at how environmentally damaged they are. So pyrometallurgy, basically you heat up all the crushed rock to such temperatures, and then you sort of physically separate the different metals by their physical properties such as density and melting point and things like that. While hydrometallurgy involves dissolving all that crushed rock into boiling sulfuric acid that you then selectively reduce the metal so that you can pull out pure metal out of each of those at different voltages or different chemical positions, and that they'll drop out as very pure metal. Now, it's very important. That involves a lot of acid. And vapor metallurgy involves vaporizing the whole crushed rock and then using carbon monoxide as a reducing agent and then sort of collecting it in a sort of a column structure as it all precipitates out as pure metal, well, close to pure metal. Now, when we look at the environmental uh, concerns of cobalt mining, there's a life cycle analysis where you look at those things. It's been done in cobalt mining in Australia because Australia keeps good records of how mining is done. There's a lot of lengthy environmental processing that you need to go through. And it's found that CO2 emissions from the electricity required to refine the materials that heat stuff up is actually the primary environmental issue with cobalt mining. Um, it's a lot of emissions to get that material pure and useful. And a secondary environmental issue is the dust and NOx emissions that could come from blasting when we blow up sections of mines so we can dig quickly, and that can throw up potentially dangerous particles up into the air that can be inhaled by the miners or anyone living nearby. And then the use of diesel as the main fuel for a lot of the mining trucks is a CO2 emissions problem as well. As a tertiary issue, it also has air pollution problems as far as the safety of breathing it in, the fumes from that. But cobalt is significantly less freshwater contamination than that of copper or nickel mining, which, if you had a look at those batteries I showed earlier, are also in lithium-ion batteries, but not usually part of what we're concerned about. But this life cycle analysis did validate that there are serious problems with a lot of particulate harming miners and anyone living nearby. So we need to really look into how we can prevent dust getting up into the atmosphere when we're doing mining. So let's talk about the Congo specifically. Now, a lot of this was covered in the original video. That was the inspiration. I'm going to go over it, but I won't go over it in depth. You should refer to that when possible. The southern part in Katanga, down here in the southern part, holds large deposits of cobalt. About 60% of the world's cobalt comes here, from here in the Congo. Large industrial mines are operated by Chinese mining companies. Now, there used to be other mining companies from Canada and Europe, but they've all sort of moved out of the area as it's become politically damaging to be operating in the Congo. The reason why there's a problem is that the construction of these mines destroy the farmland and the forests and sort of the above ground resources that all the people that lived in the area used to survive on, which ended up requiring them to go mining themselves in order to pay for food. So people, children, they dig self-mines in their backyards, under their floorboards. They go through the waste of the cobalt mines to find cobalt so they can sell, so they can pay for food because they can no longer farm on the land that's now covered in mines. Although all of this is technically illegal, there's a lack of regulation, there's a lack of enforcement. And obviously, it's quite easy to bribe and make people look the other way if you are caught doing something illegal. The miners themselves, the big miners, usually Chinese, are not providing social services for the people that live in the area. They're not getting schools, they're not getting hospitals, they're not getting transport. It's just all that money is going in the ability to take that cobalt from the ground and ship it to, well, in this case, China, where the batteries are made. So yeah, it is bad, and we should be concerned about it. But because the public and then corporate people who heard that, they were putting in that effort to make this a big deal, they're all rushing to improve their act. They're looking to be seen as good and not sourcing cobalt from these kind of artisanal mines. So companies such as Apple, Tesla, Volvo, Polestar, and plenty others have committed to responsible sourcing of the cobalt they use in their batteries. Interesting, the Chinese government themselves, the Chinese Chamber of Commerce for Metals, Materials and Chemicals, stepped in to help create this responsible cobalt initiative because their companies were being damaged by the sort of the public impression that their batteries aren't safe. The unethical batteries are coming from China. So, and one of the biggest battery manufacturers, CATL, C-A-T-L, they partnered with the auditing company RSC Global Group to audit the supply chain so they can make sure there's none of this artisanal cobalt that's being mined by children in their supply chains for their batteries. Simply because we made a fuss, these companies are doing something. However, there were continued reports of abuses happening in southern part of Congo that has led to EV companies specifically sourcing their cobalt from places other than the DRC. Um, they've had some that have signed agreements with Australian miners or miners in Canada, specifically to make sure that cobalt is definitely not coming from artisanal mining in the Congo. Now, the IRA Act in USA has made a very clear preference for electric car companies to take North American cobalt or anyone that they have a free trade agreement with. And the other way to avoid this issue is to avoid cobalt entirely. So there are some low cobalt, nickel, manganese, cobalt chemistries you can use. You can have some high nickel ones such as 622 or 811. These are the kind of chemistries that GM and Chevrolet are looking into, and they're looking to use the cobalt that is used in these batteries to be recycled cobalt from other batteries that have higher cobalt counts, allowing them to avoid having to mine new cobalt and have it come from the Congo. Other battery cathode is lithium iron phosphate. Now, lithium iron phosphate, if you have a look at here, is more of like a columned structure. So we have our iron oxide here and then our phosphate groups here. And then the lithium gets in between these gaps rather than it's more of a column structure than a layered structure, but it still conducts electricity fairly well and allows the lithium to get up in between these marginal groups, allowing it to act as a cathode. But it does have a significantly lower energy density than that of NMC cathodes, but it's been found to be a bit more robust to temperature changes, less likely to have runaway, stuff like that. So it does have an advantage of its own, it's just less energy dense. Now, LFP is about 29% of the market and rising. It's often used in buses and large heavy vehicles where the cost of NMC batteries become important and where the volume is not as important as far as energy density is concerned because they have a lot of space available in those vehicles. The world's second largest battery maker, BYD, and the world's second largest EV maker, BYD, only uses LFP batteries. Tesla is a mix of LFP and other chemistries that they use. Ford and Volkswagen are looking into using LFP batteries in their cheaper models because it's without cobalt, it's significantly without cobalt or nickel or manganese. Lithium iron phosphate is a much cheaper material to use, and we're now seeing it commonly found in the lowest priced Chinese models, and some of which are being found sold in other countries. Mining is unfortunately necessary. If you look around you, particularly if you're in a developed country, you'll find all your stuff is either made out, either it's mined or it's grown. It all comes from somewhere. And cobalt is not the only metal with serious ethical concerns. I mentioned copper and nickel with water contamination earlier, but it can even happen with iron ore. As you can see here with Juukan Gorge, and here where they destroyed important Aboriginal sacred sites because they could. Here we see BHP's had a tailings dam collapse and destroy many villages and killing people. But mining, so it would be really nice if miners were significantly less evil. But mining is a lucrative business, which means they have the money to influence governments to avoid regulations or prevent them from ever being put into place in the first place. I'm in Australia, we have a developed country, and still the mining companies have undue influence on our political system. And in countries with significantly less institutional power than Australia, with weak democracies, we may see the case of full state capture, where mining companies are so important to those developing countries' economy that no party in the democracy will even consider putting any kind of regulation on those miners because they're just too important for those countries to function. So here is an interesting thing that I think is really important to consider if you are an environmentalist and you're concerned about climate change but also concerned about the damage that mining does, is that we're going to need 4 to 6 times as much materials to reach our net zero targets by 2050. You can see here we have 6 times and 4 times here. And this is how much of a material, how much more times that our current production we're going to need to reach even this mild target here of the 4 times the Sustainable Development Goal. But I want to point out very firstly that predicting the future is very difficult. We don't actually know how much of these materials we're going to need. A lot of earlier analysis I've seen required a lot more cobalt than this, but because of the rise of LFP, because batteries are getting far more energy dense and electric cars are becoming more energy efficient, we're actually seeing that we need far less cobalt than we thought we were going to need. Renewable energy, storage, and importantly, transmission take a whole lot of materials. But electric cars are actually one of those devices that take a lot of critical materials of many different types. Lithium, graphite, cobalt, nickel, rare earths, they're all in electric cars, while only some or a few are in these wind or solar PVs. But it's important to remember that these materials are not being consumed. They will still be there, but we need to raise the recycling percentage of these materials that we currently have. I think some are around 30, 34, 35% in the high levels, particularly if they're expensive metals, but we need to go much more than that so that we do not need to mine quite as much. It's also important to pretend that we will then be replacing extraction of fossil fuels. We won't need any of that oil, gas, or coal mining, and generally this displacement of materials is sort of replacing that. And even with the sort of dirtiest electricity in the production of the materials, we're still producing less greenhouse gas emissions by using more of these materials than we would by just burning fossil fuels instead, which a lot of videos seem to miss out when they're trying to make this point. So how can we make mining better? Well, mining doesn't need to be so carbon intensive. We can use renewable electricity to produce the energy and the heat we need to do that processing of rock. But we can also do EV mining. So this is a fully battery operated mining truck. It's made by Fortescue Metals and Williams Automotive and Liebherr. That is this fully electric mining truck that removes diesel, that if we were to charge it 100% renewable energy, will then remove that source of CO2. It can also be charged in about 30 minutes, which I'm pretty impressed with considering how large the battery is in one of these. Another way that we can reduce emissions is the choice of production pathway in the refining process. Not all refining processes are the same. Some use more energy, some use more acids and dangerous chemicals when they're doing it. Another big use of mining is obviously the land use. Now, open cut mines take up far more land than underground mines, but it's not just that. There's also the waste rock that goes into that. Where does all the rock that you dig out go? That takes up some more land. So when we consider building the mine, how much of the environment it has to destroy just to exist is something that we're really going to have to try and minimize when we're looking at mining. Water use and contamination. So I think we mentioned before, I think it's come up a lot that lithium, for example, uses a lot of wastewater, and things like copper and nickel tends to contaminate water because they can be ecotoxic when they get into water. So they must not end up contaminating rivers and streams and local groundwater or drinking water. So when doing mining in a green way, we really need to see if we can have a kind of closed loop water design so that we can clean up the water and put it back to use again. We can recycle that water so we don't end up with these large tailing ponds that can be quite dangerous, as we saw with the BHP disaster. Something that's a bit harder to stop is all the dust that's kicked up when mining. That we mentioned before, that's dangerous for the miners, it's dangerous for anyone living nearby, that can get into people's lungs and therefore into their bodies, particularly when mining something that might be toxic. A lot more has to go into the work of reducing the air pollution from mining than we currently do. overall, these risks and consequences should be minimized, and they should be going through a difficult regulatory process in order to get those mines done. Even if we do need large amounts of minerals quickly, we still cannot give up on this regulation that is critically important, protecting the environment and protecting people. Which brings me to what we're going to do in the short term. What's the conclusion of my talk? First of all, we must end the grip of fossil fuels, and to do that, we are going to need a lot of materials. But we can't do that at the expense of the environment and workers in developing countries. So, it's very important that we do ask for accountability from battery and EV makers that they're not using minerals that is greatly damaging environment and people, like they have, at least in the past, doing in the Congo. Now, one of the ways they can do that, of course, is to replace cobalt completely in EV batteries. If you are personally concerned about cobalt, you can choose to buy a EV with an LFP battery. They're quite good, quite affordable kind of EVs. When it comes to greening up mining process in general, we can swap to EV and renewable energy mining. Unlike fossil fuel production, mining is not inherently a high CO2 process. It's just high CO2 in the way that we currently do it. Finally, we must improve environmental and workers' regulations, particularly in developing countries, but really everywhere. It's a problem everywhere. The power of mining companies like to avoid regulations when they can. They pay small fines when they breach them. We must always keep our eye on what the mining companies are doing, and what we can do to protect our local environment. Medium term. So I think one of the big things you notice when you look at these mining companies is that they're multinational mining corporations that do not have multinational regulation, which allows them to simply go to a country like the Congo and not really be properly regulated in their behavior. We need to see international environmental regulation. Now we see a little bit with things like the Paris Agreement here, where we're seeing a little bit where we're seeing countries all agree to reduce greenhouse gas emissions. But we also need to agree to not destroy forests for mining and not damage waterways with these mining processes. Because water is very important, and that also needs to have these kind of large environmental agreements around it in order to prevent that from happening. Now, one of the things that comes up a lot in these kind of videos, and I did see in the original inspiration video, was talking about that unequal exchange, or that a Congolese worker is not getting paid as much as an Australian worker. I don't really think a Congolese worker should be paid more than an Australian worker. It's all really about what the cost of living is in the country that resides. But their life is worth the same, in that they're both priceless. And so worker safety regulations really should be just as strong in Congo as it is in Australia. Because I want to see every worker go home at the end of the day, work to their family. And if we don't get this kind of international agreement to make sure that workers are safe in whichever country they reside in, people are dying. And that, I think, is unethical to happen. And we need international anti-corruption regulation. Now, again, similar to the things that we see many multinational corporations effectively capturing states of developing countries and then effectively being able to run without rules. This kind of corruption is quite horrific, and we need to prevent this kind of imposing the power of a mining company over a democratically weak nation where they can. And this might be able to be enforced in international agreements. Now we need, as some countries do have strict product origin regulation and supply chain tracking, so we can make sure that no blood materials or materials from unregulated mines are getting into the global supply chain. And we see that this kind of process is being built as we go. We're going to see more of it. I would prefer more government involvement rather than private companies deciding to take it on themselves after criticism. But then we come to the really tricky thing when it comes to international governance. It cannot be seen as a new form of colonialism or opposing power from above. I think when we take this look at something of so say the European Union, which is a bit of an experiment in international governance, we can see that, um, I mean, countries like Britain decided to leave the EU because many of the people felt frustrated by being imposed upon a regulatory structure from Europe. But even currently within Europe, we see often that countries like Poland will reject regulations from Europe, citing some of the historical horrors that Germany had imposed upon Poland as justification for rejecting that kind of regulation. So we can't have a sort of international agreement all made by developed countries to then impose that regulation onto developing countries, even if those developing countries may have an issue with corruption. We need to have the people that live in those countries come to want the regulation themselves and then ask for help from the international community in order to impose those regulations on a company that is acting internationally. And there will be any attempt to regulate international will be met with an opposition from the right wing. We will see the global elites imposing rules upon what I can do in my own home kind of rhetoric. We already do. Some of it is a little anti-Semitic. This kind of attempting to have international governance really brings up this kind of return to nationalism rhetoric because people really struggle connecting with why some regulations might be needed or why a regulation might be needed in your country and then it's not being implemented properly in another country because of the way that it works. So we need to really foster a grassroots movement for more regulation within the countries that need better regulation, that need help dealing with state capture from mining companies. And finally, we'll talk about the future. So these are the two possible futures, as I call them. We have the green growth future and we have the degrowth future. So many people on the left, we're going to kind of have a long debate about which of these is the best way to go forward. Now, both of them agree that we need environmental sustainability. We're all in the fight to stop climate change. We need better environmental stewardship, and we need to responsibly use our limited resources. But green growth and degrowth take different paths towards achieving that. So green growth really does want there to still be economic growth, and I want to see development in developing countries to improve their standard of living. But they need to make that economic growth that also accounts for the importance of the environment when making economic decisions. And eventually, the ultimate goal, of course, is to decouple economic growth with environmental damage, with energy use and material use and CO2 emissions. They need to be decoupled from each other. And to do that, you're going to need technological advancement. And generally, green growth prefers to have support from government rather than government doing the work. So government will help businesses invest it in these projects to get them over that little capital expenditure requirements to start using better methods in order to reduce their environmental impact, but will then not be the ones doing the sort of central planning around that. Well, degrowth is really focused on that it's impossible to have infinite growth on a finite world. So they want to see the end to the very idea of infinite growth. And they want to see a reduction in the total production consumption of really everything. They want products to last longer instead of they want them to be extremely repairable, easy to get replaceable parts, so that we can keep reusing the same things over and over again. And so they prioritize well-being, social equity, and ecological health as the main driver, rather than say a line goes up economic approach to how things are going. We want everyone to have their basic needs met. We want the environment to be clean and easy to live in. Very important to them, of course, is the equitable distribution of resources, and they prefer local supply chains instead of shipping things all around the world. Both of these things, I think, do have concerns and problems. So I have not decided which I prefer. The problem with green growth is quite obvious, is inequality. That you can have, let's say, a business put solar panels on the roof, they can power their entire um, the entire factory by using that solar power. They no longer need to pay for expensive power. Where does that economic advantage go? If it goes immediately to the owners of the factory and none of that's passed on to the workers, we see a kind of pulling up. We see an increase in inequality because the owners are paying less, but the workers are being paid the same. We need to have a way to bring that economic efficiency that's been generated by green growth, where we use less materials, we use less or cheaper power. We need to funnel that back down to the bottom to allow everyone to participate in the green economy, including developing countries. We can't have a case where developed countries are now using high-tech manufacturing techniques that use way more materials, but everyone else still has to use the old ways. They still use a lot of CO2, still produce a lot of CO2, still use a lot of materials to get things done. The problem with degrowth is, well, firstly, I like efficiency, and I don't like the idea of deliberately making your economy less efficient, particularly when it always runs the case that someone will simply run their economy more efficiently and overtake you, gain more power, which will get into political problems. And it's really the local production one that bothers me the most, though. Because let's say you have to build 100 local factories, or you could build one large factory in China. Building one large factory in China could quite well be far more materially efficient, and certainly more energy efficient, than having hundreds of small factories. Although that might be likely that you personally are to benefit from that local factory, you are not actually being as responsible with your resource use as you possibly could be. I also find that I consider international trade critically important to benefiting developing countries and the world in general. And this kind of inward looking economic ideas always makes me concerned for the ability of developing nations to grow, and also the ability of those multinationals to take advantage of them when we're not all interconnected in the way that we are. So I want to thank you for listening. I haven't decided what my next video will be on. Something will jump out at me as an inspiration. I'll get to work at that. I have a few ideas. If you have some ideas, put it down in the comments below. Tell me if the audio was better. Tell me if you liked the eyes moving. Tell me what you think about degrowth and green growth, because try and convince me which way to go there. You have any ideas how to better improve international governance when we're dealing with people that kind of struggle with the idea of an internationally connected world? I hope you have a good day.